question is, let V1 is equal to column matrix 1, 2, 0 and V2 is equal to column matrix 2, 1, 3, be two vectors. The value of the coefficient alpha in the expression V1 is equal to alpha V2 plus E, comma, which minimizes the length of the error vector E is. ABCD options given. This is from engineering mathematics from the topic linear algebra, subtopic basics. And the solution is and this is application of two chapters, linear algebra basics as well as maxima minima calculus. So these are V1, V2. Vectors means either column matrix or row matrices. Now we are going to find alpha, for which this expression minimizes, that is minimum, minimizes the length of the vector E. Minimizes the length of vector E. Okay, the solution. You know how to find length of a vector. Square root of sum of the squares of the elements of a vector. So, given this, V1 is equal to alpha times V2 plus E. From this, I can find E value is equal to V1 minus alpha times V2. Alpha is a scalar. Okay. V1, V2 are two column vectors. Now, this is V1 column matrix 1, 2, 0 minus alpha V2 means every element of V2 multiplied by alpha, that is, which is giving 2 alpha, alpha, 3 alpha. Just like difference of the two matrices, corresponding elements to be difference. Take the difference 1 minus 2 alpha, and this is 2 minus alpha, and this is minus 3 alpha. Now this is again a column matrix, column vector. Now, length of vector E is denoted by, this is the symbol. Both sides two parallel lines. Norm symbol. Length is also called norm, which is defined as square root of sum of the squares of the three elements. 1 minus 2 alpha whole square plus 2 minus alpha whole square plus minus 3 alpha whole square. Okay. So this is the main key point. Length of E. Okay. Now this simplifies to a minus b whole square, a square plus b square plus 2ab minus 2ab. So this simplifies to 14 alpha square minus 8 alpha plus 5. This is 1 square, 2 square, 5. So this is the length of the error vector E. Okay. So this is error vector. Now this square root is there. Now to make this minimize length of the vector, generally in maximum minimum, whenever there is a square root problem, try to convert into square of that problem. That is considered the square of this expression. When the square of that function is minimum, then that function is also minimum generally. Okay. So now I am taking a function, one variable function alpha. This is a function of alpha which is under square root. So I am considering the new function square of this length of the error vector E, which becomes 14 alpha square minus 8 alpha plus 5. So here one variable function. Okay, that variable is alpha. Now for maxima or minima, the necessary condition is f dash alpha is equal to 0 for obtaining stationary points. First derivative with respect to alpha. So this becomes 28 alpha minus 8 alpha, derivative is minus 8 equal to 0. So from this you will be getting alpha is equal to 8 by 28, 4 2s are 4 7s are. So this is the only stationary point. Okay, is the only stationary point, that is STBD. Actually, at this stationary point, definitely this f of alpha, that is square of the length of the vector, is going to be minimum because we got only one stationary point. Okay. and one of the option is there, 2 by 7. Let us check the second derivative is correct or not. Now, f double dash alpha. If second derivative greater than 0, then that function is going to be minimum at that point alpha. So 28 alpha derivative is 28 minus 8 derivative 0, which is greater than 0. So implies f of alpha, okay, is minimum without substituting alpha, because f double dash alpha is the second derivative constant at alpha is equal to 2 by 7. Now they are asking f of alpha means square of the length. When the square of the length is minimum at alpha is equal to 2 by 7, automatically length of that vector length is also minimum at that alpha is equal to 2 by 7. So this is nothing but length E square. So therefore the length of the vector error vector E that is norm E is minimum when alpha is equal to 2 by 7. So this is the answer. So correspondingly the option is C. This is the end of the question. So now I am going to discuss GATE 2023 Electronics Communication Engineering stream mathematics questions, engineering mathematics questions. The question is the rate of increase of a scalar field f of x comma y comma z is equal to xyz in the direction b bar is equal to 2 comma 1 comma 2 at a point 0 comma 2 comma 1 is. 4 options ABCD given. This is from vector calculus topic. Subtopic is vector differentiation, directional derivative, etc. The solution is rate of increase of a scalar field in the given direction is always nothing but rate of change of phi in the given direction. Rate means automatically change. So this is the derivative in the given direction. Derivative of f in the given direction, which is also called directional derivative. So first of all, we have to find del f for the given scalar field. F is a function of 3 variables, so del f is a 3D vector. I cap dou f by dou x plus j cap dou f by dou y plus k cap dou f by dou z. Now, with respect to x, partial means yz constant, with respect to y, xz constant, with respect to z, partial xy constant. So you will be getting I cap into yz plus j cap into zx, k cap into xy. So with respect to z, z derivative 1, with respect to y, y derivative 1, with respect to x, x derivative 1. Now they are asking at a point 0, 2, 1. Let us denote that point P 0, 2, 1. So substitute x0, y2, z1 in this del f. That is gradient f or del f. So y value 2, z value 1, 2 I cap, x value 0. The last two terms absent. So you will be getting only in the direction of x-axis only, this del f vector. Okay. Now, given direction. Direction means vector. Directed line segment is, this is V. V means I can take V bar also to understand in a better way. So vector can be represented in a 3D point representation or just like 2i cap, j cap, k cap, like that. 2i cap plus j cap plus 2k cap. So find the unit vector in the given direction. Implies e cap is equal to v bar. So instead of this v, I have taken v bar. So this is meaning that point 2 comma 1 comma, that is the direction 2 comma 1 comma 2. So v bar by mod v bar. So 2i cap plus j cap plus 2k cap divided by square root of 2 square plus 1 square plus 2 square, or first find del v bar and then write e cap vector. So square root of 9, 3, 1 upon 3 multiplied by 2i cap plus j cap plus 2k cap. So this is easy question 2023. Okay. Now, therefore, required directional derivative, or what they ask directly, required rate of increase. Required rate of increase. That means the rate of increase of a scalar field f in the direction v is equal to 2 comma 1 comma 2. Instead of writing this sentence, I can say required rate of increase. Okay. So this is e cap dot del f, which is nothing but directional derivative procedure, which is nothing but exactly directional derivative they asked. So dot product, you know that 1 by 3 into sum of the products of the corresponding coefficients of I, j, k respectively. So 2 into 2. Remaining in del f, j, k cap absent. So that products become 0. Dot product becomes 0. So final dot product is 4 by 3. Any option? Okay. Accordingly, the answer is option B. Okay. So this is the key point. Given direction. So we have to find unit vector in the given direction. This is direction. I have denoted the direction by v bar. And this is the final required rate of increase. Okay. You know del f. This is 3D. Function is a 3 variables. So accordingly, the option is B. This is the end of the question. Question is, let omega power 4 is equal to 16j, or we can read w power 4 is equal to 16j. It's not omega, better to say w. Which of the following cannot be a value of w? 4 options A, B, C, D given. So this is from engineering mathematics, from the topic complex variables, subtopic basics. Now solution. Okay. Given w power 4 is equal to 16j. Okay. Implies w is equal to 16j whole power 1 by 4. J is imaginary number. So when we want to find square root, cube roots, nth roots of a complex number where j is a complex number which is purely imaginary, this 4 will go to right side, become 1/4, that is 4th roots of 16j. So first of all, 2 steps procedure. One step is express this 16j as polar form, and then in general form, polar coordinates. Okay. Modulo amplitude form in general form, that is adding 2k pi. Then proceed finding nth roots of unity by De Moivre's theorem. You will be getting 4 values for w. So this I can write Just like I is nothing but e power I pi by 2, cos pi by 2 plus I sin pi by 2 is nothing but I only. So j is can be written as 16 into cos pi by 2 plus j times sin pi by 2. Sin 91, cos 90, 0. This is modulo amplitude form where 16j modulus is 16. That amplitude theta is pi by 2. Okay. Next step. Adding 2k pi. Cos pi by 2 plus 2k pi plus j sin pi by 2 plus 2k pi. Okay. We know that cos theta plus j sin theta I sin that is e power I theta. That is Euler's representation. So can I write it directly like this? E to the power j times pi by 2 plus 2k pi. Okay. Since e power I theta is equal to cos theta plus I sin theta. Here 2k pi means multiples of 2 pi, adding or subtracting won't change in the position, but theta value are many, infinitely many argument value sin theta. So therefore this omega, that is w, is equal to 16 e to the power j times pi by 2 plus 2k pi bracket close and main bracket to the power 1 by 4. 16, fourth root of 16 is by 2. Now this is remaining term a power m whole power n, nothing but a power mn, e power j times this 1 by 4 multiplied with pi by 2 plus 2k pi along with j. Okay, so this is pi by 8 plus k pi by 2. What are k values? Because that power 4 indicates 4 values for w. So starts from 0, 1, 2, 3. This is n minus 1. So this looks like I can denote nth roots of a complex number 16j. So this 3 is nothing but n minus 1. So refer that procedure. K value 0 to n minus 1. Next. So giving 1 by 1 values there. K is equal to 0 gives W is equal to 2 times e power j pi by 8. E power j pi by 8. Yes, this is already there. They are asking cannot be a value. Okay. Now k is equal to 1 gives, putting k is equal to 1. So pi by 2 plus pi by 8. 2 into e power j into pi by 8 plus pi by 2. Pi by 2 can be written as 4 pi by 8, or you can take LCM. So this is simplifies to 2 into e to the power j 5 pi by 8. Okay. So this is also there in the option. Next, k is equal to 2 gives w is equal to 2 into e to the power j into pi by 8 plus pi. So pi by 8 plus pi simplifies to 7 pi by 8 by taking LCM 8. 2 into e to the power j into 7 pi by 8. Okay. Not 7, 9 pi by 8. Okay. 9 pi by 8. Next, this is also in their option. K is equal to 3 gives W is equal to, here put K is equal to 3, 2 times e to the power j into pi by 8 plus 3 pi by 2. LCM is 8. So 1 pi plus 4 into 3, 12 plus 1, 13 pi. Finally simplifies to 13 pi by 8. Okay. So this is not in options. Okay. Therefore, W is equal to 2 into 13 pi by 8. Okay, is not in option. The first three are in options. And A option we didn't get. We got in place of 2 pi by 8, 13 pi by 8. Okay. W is equal to 2 times e to the power j times 2 pi by 8 is not a value of, okay, is not a value. Or you can write 2 into e power j into 2 pi by 8 is not a value of W. Okay. So, accordingly, A is the option. This is the answer. So, this is the main point. Cos pi by 2 plus sin pi by 2. Okay. I can write here since j is equal to e power j into pi by 2. You can begin with like this also, e power j pi by 2, or we are well remembered these cos 90, sin 90. You can write, you can start like this also. And the next key point is this one, adding 2k pi. After this one. Okay. So finally the answer is option A. This is the end of the question. The question is the value of the contour integral over c z plus 2 divided by z square plus 2z plus 2 dz, where the contour c is set of all z such that mod z plus 1 minus 3 by 2 j mod is equal to 1 taken in the counterclockwise direction is. This is from engineering mathematics, from the topic complex variables, subtopic complex integration. Using, you can evaluate the integral by Cauchy's integral formula or Cauchy's residue theorem. Here the curve is a circle having center is minus 1 plus 3 by 2 j and radius is 1, comparing with mod z minus a is equal to r value 1, radius, center is minus 1 plus 3 by 2 j, where j is imaginary part. So solution. Curve C is, that is curve equation is mod z minus of 1 plus minus 1 plus 3 by 2 j is equal to 1. Center at minus 1 plus 3 by 2 j and the radius is equal to 1. So this is a circle, first of all. Comparing with circle equation in complex form, mod z minus complex coordinates. Okay. Mod z minus a is equal to r. Now, so I want to evaluate by residue theorem. Before that, find the poles of the, find the singular points of the integrand. This is our integrand f of z. Okay. Now, denominator. What is denominator? Z square plus 2z plus 2 is equal to 0, which is a quadratic equation whose roots are obtained by either factorization or minus b plus or minus root over b square minus 4ac by 2a. You will be getting minus 2 plus or minus root over d square minus 4ac by 2a. 4 minus 8 is minus 4. Root minus 4 is 2i. So 2 is common and then cancelled. In place of I can write j because j is denoted by here, imaginary part, divided by 2, which implies z is equal to minus 1 plus j, comma, minus 1 minus j. Okay. are the singular points of the integrand. So I am using Cauchy's integral formula. We can evaluate by Cauchy's residue theorem also. These singular points are also called poles of order 1. These two singular points obtained from equating denominator to 0. The denominator having whole power 1. The power of the denominator factor is 1. So that's why each singular point is a pole of order 1, because numerator, denominator, finite power subject. Okay. So now check whether these points inside or outside, or at least exactly one point inside, like that. So if I put minus 1 plus j in this, okay, j minus 3 by 2 is minus of j, mod minus of plus 1, mod j value 1, so less than 1. And if I put minus 1 minus j, this is greater than 1. So only z is equal to minus 1 plus j lies inside C. Okay, you can draw the circle diagram and you can locate these points and check that whether inside, outside, or alternative procedure. Okay, for z is equal to minus 1 plus g implies the curve equation. Substitute this z point in the curve equation. Check whether LHS less than RHS. So z plus 1 minus 3 by 2j simplifies to minus 1 plus j plus 1 minus 3 by 2j. So this is j minus 3 by 2j is minus 1 by 2j mod nothing but half, which is less than 1. This is RHS of the equation. This half is LHS of the equation. Whenever LHS less than RHS, such a singular point lies inside. Now you can check this is outside. This point lies outside C. Just like here, you can show that. Okay. So this is center, radius. Okay. These are the two singular points. This is only inside. Now, therefore, we have to write this integral as standard form of Cauchy's integral formula, that is f of z by z minus a, etc. Because the power of the denominator factor is 1. Integral over c, z plus 2, numerator no change, but denominator is a second degree factor. Already 2 z values, 2 roots are there. So this quadratic factor can be written as product of two linear factors. Z minus of first factor is minus 1 plus j into second factor z minus of minus 1 minus j. Can I write like this? Whenever a quadratic equation having two roots, alpha, beta, then that quadratic equation can be written as x minus alpha into x minus beta, provided x square coefficient is 1. Here z square coefficient is 1, dz. So write the generally to compare, to write this integral as Cauchy integral formulas notation, which factor in the denominator, which factor to write in the numerator, how you decide. So write the factor corresponding to a singular point inside the curve in the denominator, other factors in the numerator. Okay, so this minus 1 plus j, we already verified this is inside C. So write this factor, keep this factor only in the denominator, shift this second factor into the numerator. So this can be expressed as z plus 2 divided by z minus of minus 1 plus j, put it in bracket, whole divided by, oh sorry, this is numerator. We have to put this first factor in the denominator, this is shift into numerator. So this is better to write minus 1 minus j. Now this denominator is z minus of minus 1 plus j dj. Now this looks like Cauchy's integral formula, where numerator fraction is denoted by f of z, denominator factor is denoted by z minus a. So this point is a. Now what is your answer? 2 pi I into f of z. Okay. So this is nothing but 2 pi I. In place of I, we have to multiply j. We have to write j. F of j. J means what is this? Singular point minus 1 plus this is the singular point. A is the singular point. Okay. So once if I denote A in Cauchy integral theorem or Cauchy integral formula, that point lies inside the curve. Okay. So using Cauchy's integral formula. So this, how do you find f of minus 1 plus j in this numerator fraction f of z? Put z is equal to minus 1 plus j. So this is 2 pi j multiplied by, now numerator is z plus 2. In place of z, put minus 1 plus j. Minus 1 plus j plus 2 divided by, in denominator factor z minus of minus 1 plus j, there put z is equal to okay. So in the denominator of the function f of z is z minus of minus 1 minus z. In that, put z is equal to minus 1 plus j. So minus 1 plus j minus of, already there is minus 1 minus j. See this one. This is f of z. F of minus 1 plus z, how do you get? In this f of z, wherever z, put z is equal to minus 1 plus j. So minus 1 plus j plus 2. This is okay. In denominator also z minus 1 plus j and the remaining as easily. Okay, because this is your a. Now this simplifies to 2 pi j numerator 1 plus j divided by denominator. Minus 1 plus 1 got cancelled. This is 2j. 2j, the prefactor 2j cancel, pre-multiplication factor. You will be getting pi times 1 plus j. Okay. So this is the answer. Accordingly, the option is B. This is the end of the question. Eigenvalues and eigenvectors of a matrix B. Set lambda k such that 1 less than or equal to k less than or equal to n, and vk, set of all vk such that 1 less than or equal to k less than or equal to n respectively. For any invertible matrix B, the sets of eigenvalues and eigenvectors of the matrix A, where B is equal to P inverse A into P respectively are. 4 options given. This is from engineering mathematics from the topic linear algebra, subtopic eigenvalues, eigenvectors, properties. The solution is, so first observation, B is the P inverse into A into P. P is inverse exist, invertible matrix. Okay. So already B matrix, eigenvalues, lambda 1, lambda 2, so on lambda n, which is an n cross n matrix. Eigenvectors usually denoted by capital X. In place of capital X, they have denoted by V symbol, so that V1, V2, V3, so on, Vn are the n eigenvectors correspondingly to the n eigenvalues lambda 1, lambda 2, so on, lambda n of the matrix B given. Okay. See. Just according to the properties of eigenvalues, eigenvectors, B and the matrix A and B matrix are called similar matrices. Similar matrices having same eigenvalues. Okay. So that's why the eigenvalues of the matrix A are nothing but lambda k, set of all lambda k, 1 less than or equal to k less than or equal to n. Here, by the definition of similarity matrices, similar matrices, A and B are similar matrices. A matrix B is said to be Similar to another matrix, say square matrix A of order n. If there exists a non-singular matrix P such that B is equal to P inverse into A into P. So therefore, by properties of eigenvalues and eigenvectors, comma, 1. First point, A and B. B is nothing but P inverse into A into P. Have same eigenvalues Number 2, if usually X, capital X, is an eigenvector of matrix B. B is nothing but P inverse into A into P. Then Px is corresponding eigenvector, an eigenvector of matrix A. This is the properties in eigenvalues and eigenvectors, one of the properties. Okay. Px is an eigenvector of A. So therefore, from these 2 points, we can conclude lambda k for 1 less than or equal to k less than or equal to n. That is lambda 1, lambda 2, so on, lambda n. The set, okay, are the eigenvalues of matrix A. So in all last 3 options we have lambda k, but P into X, I denoted eigenvector by X. E has given eigenvector of the matrix B, that is B has eigenvector notation for the matrix B, the eigenvector denoted by Vk. So for the corresponding eigenvector of the matrix A is P into Vk, because if X is eigenvector of B, then P into X, in place of X, he has given Vk. Okay. And P into Vk or new symbol also, new symbol. If you compare with alpha, beta, gamma, Greek letter, this is new k or Vk. P into Vk for 1 less than or equal to k less than or equal to n. Okay, this is also I can write in set, are the eigen vectors of the matrix A. Okay, of the matrix A. Or if you are not satisfied in exam, if you do not remember this result, don't worry. If A is the square matrix having eigenvalue lambda and the corresponding eigenvector x, then the relationship between these three is Ax equal to lambda x. So to prove that a vector x is an eigenvector of the matrix A corresponding to lambda, it is enough to show that Ax equal to lambda x. Okay, so I can do that also. Or alternative method C. Consider we want to prove P into Vk is an eigenvector of the matrix A. It is enough to show that A into P into Vk is equal to lambda k into P into Vk. Okay. So A into P matrix into Vk is the eigenvector. Vk is an eigenvector of the matrix B. Okay. Now we have to get P inverse AP. So there is a P already. I can write this is I into A into P into Vk. Identity matrix, where I is the identity matrix? I into A is nothing but A. And this again I can write I. P into P inverse. A matrix into its inverse is nothing but identity matrix into A into P into Vk. And this term I can write P inverse into A into P is already given B. Okay. So this is P into B into Vk. Okay. Now, what is Vk? Is an eigenvector of lambda. So this is P into lambda k into Vk. Since P has E vector, that is the eigenvector, Vk corresponding to E value lambda k. Therefore, the relationship between matrix eigenvalue, eigenvector is B into Vk is equal to lambda k into Vk. Am I correct? Ax equal to lambda x definition. So now this I can write lambda k into P into Vk. Now just observe the left hand side and right hand side relation. A into, say this is x, we got lambda into x. So therefore P into Vk is an eigen E vector of matrix A for k values, that is 1, 2, so on n. That is 1 less than or equal to k less than or equal to n. So finally P into Vk, lambda k is the set, this set is eigenvalues and this set is eigenvectors. So accordingly the answer is option C. This is the end of the question. The value of the line integral P to Q z square dx plus 3y square dy plus 2xz dz along the straight line joining the points P112 and Q231 is 4 options given. This is from engineering mathematics from the topic vector calculus. And the solution is line integral. So either you express this f bar dot dr bar. Actually this is f bar dot dr bar. Okay. Already given in Cartesian form. So express this integrand in variable separable form or exact differential, that is derivative of some function, or one variable terms only depending on the curve equation. Okay. So I can write directly this is integral P to Q z square dx 3y square dy plus 2xz dz. Already curve is given straight line joining these 2 points. Straight line joining 2 points, you know that x1 y1 z1 x2 y2 z, z2 x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. Using that, you will be getting this expression into one variable terms. That is one method. Second method is, for this problem is there. I can express this integrand, that is z square dx plus 3y square dy plus 2xz dz as derivative of some function using standard exact differentials. Once you express like that, that derivative and this integration got cancelled and just substituting upper limit lower limit by normal integration method. Let us see. Here this term is variable separable. This is y terms multiplied by dy. This is one of the variable separable. Z and x are not variable separable terms. So, but I can write UV rule using standard exact differentials. So, this is equal to integral p to q z square into derivative of x. dx means derivative of x. There is no pre-multiplying x terms. So, write as it is like that. Don't simplify this z square dx. But now I am writing this third term after z square dx because these are two variables z and x terms. This 2xz is containing derivative of z. So, its pre-multiplication 2z is there. Using exact differential, 2z dz can be written as derivative of z square. So, this is x into derivative of z square. The remaining 3y square dy. Even though is variable separable, we can write derivative of some function. 3y square is the derivative of y cube. So, 3y square dy I can write derivative of y cube. Now, this first two terms looks like z square into x derivative plus x into z square derivative. UV rule, product rule differentiation. So, this is p to q derivative of x into z square. And this is already derivative of y cube. Just see this term, okay. Now, so this can written as p to q derivative of sum of the derivatives can be written as derivative of some functions, derivative of the sum of the functions, and this d derivative integration got cancelled. You will be getting simply xz square plus y cube. Substituting upper and lower limit q point is 2, 3, 1, p point is 1, 1, 2. Now put x2, y3, z1, that is upper limit. So this is 2 times 3 square 9 plus, sorry, z value 1, 1 square is 1. 1 plus y cube, 3 cube is 27. So this is upper limit simplification minus, now putting lower limit x value 1, y value 1, z value 2, 1 into 2 square 4 plus y cube 1. So this is 29 minus 5, 24. Okay. So there is an answer. Option B. Alternative method I am telling you. You can try later. So C is straight line. C means curve. Okay. PQ implies equation is x minus x1. This is first point x1 y1 z1, second point x2 y2 z2. 2 minus 1, y minus 1 by 3 minus 1, z minus 2 by 1 minus 2. So this can be written as x minus 1 by 1, y minus 1 by 2, z minus 2 by minus 1. So expressing yz in terms of x, that is one method. Using that will take more simplification. That means you may get silly mistakes also from these two, y value in terms of x, and from first and last term find z value in terms of x. So sometimes that procedure will make difficult. It is not difficult. Will take more calculations, more number of steps. It is better to take this is t in play. All these three equal to t. So from this, find x, y, z in terms of t, third variable, fourth variable. So I want to express, I told you, all are in terms of one variable terms. So t plus 1, y value, 2t plus 1, z value, minus t plus 2. Okay. So, and t limits, 0 to 1. Just in any of these x, t, y, t, z, t, substitute x lower limit, x upper limit, or y limits or z limits, you will be getting corresponding t limits 0 to 1. And dx, dy, dz, you know, dx is dt, dy is equal to 2 dt, dz is minus dt. So therefore, you will be getting the finally again 24. So the answer is 24. This is end of the question. And real matrix, real column matrix, vector with length L is equal to square root of x transpose x. The trace of the matrix P is equal to x into x transpose is. 4 options given. This is from engineering mathematics from the topic linear algebra, subtopic basics. The solution is, here x is a column matrix. Column vector means column matrix. N cross 1. N rows, 1 column. So sometimes we have to consider a particular case, that is 2 cross 1 matrix, 3 cross 1 column matrix. N cross 1 means we don't know n value. Okay, I can take x is equal to some x1, x2, so on, xn, that is n elements, which looks like a problem is lengthy in that case, general case. So better to take particular case, that is 2 elements column matrix, 3 elements column matrix maximum only, because we finally want one of the options is the answer. They don't want the procedure in general case, okay, because of 2 marks, 1 marks also. Let us consider particular case. Consider a 2 cross 1, that is n is equal to 2, column vector x is equal to x1, x2, 2 elements. 2 into 1 means 2 elements are not. So first row, second row, only 1 column. Instead of considering n cross 1, if I consider, okay, you can take x is equal to x1, x2, so on, xn, n elements also, n components also, column vector. But finally you will be getting the answer. We'll take more number of steps. It doesn't mean that more number of steps. The calculation takes more time. That is. Now, what is x transpose? Row vector x1, x2. So there is P matrix x into x transpose. There is length is equal to x transpose into x. X transpose into x. That is row matrix x1, x2 multiplied with column matrix x1, x2. So finally this gives one element, single element. This is also called length of a vector definition, square of the length of the vector, x transpose into x. So length of a vector x is denoted by norm x symbol and is defined as square root of x transpose into x. So this is first row into this column, x1 into x1, x1 square plus x2 into x2, x2 square. Okay. So, you know this length of a vector, square root of. Okay. So, which implies L is equal to root over x transpose into x is nothing but root over x1 square plus x2 square. Okay. Now only one option C containing L, remaining options L square. Let us see. Now, matrix P is defined as x into x transpose. X means column matrix x1, x2. X transpose row matrix x1, x2. So, which give this is 2 into 1, 1 into 2, 2 cross 2 matrix you will be getting. If I consider the n cross 1 column matrix, you will be getting n cross n square matrix P. Time consuming and confusing also. You will be getting confusion also if you take general case n cross 1 matrix. Total n into n square elements. It is writing that n cross n matrix also takes more time. So first row into first column, x1 into x1, x1 square, first row into second column, x1, x2. Second row of this column matrix multiplied by first column of the second matrix. x2, x1 is nothing but x1, x2. Second row multiplied by second column. Only each row column containing, that is here, one element. Okay. x2 square. Now this is a 2 cross 2 matrix. Now trace of a square matrix. This is a square matrix or not? Trace of a square matrix is defined as sum of the diagonal elements, principal diagonal elements, which implies trace of P, matrix P is, these are the two diagonal elements, add these two elements, x1 square plus x2 square. Trace of a square matrix A is defined as sum of the principal diagonal element, SUM sum. So, which is nothing but L square. L is already, we got square root of x1 square plus x2 square. This is length of x. Okay. This is the length of vector x. Okay. Now this becomes L square. Okay. So finally we got trace of P is L square. Understood or not? Okay. So the answer is option A. Accordingly, this is the end of the question. Value of the integral double integral over R xy dx dy over the region R given in the figure is rounded off to the nearest integer. This is a numeric question. So this is a plane region given. It is a square. Let us check. This side line y is equal to x, and this is y is equal to minus x, y is equal to x plus 2, y is equal to minus x plus 2, bounded by 4 straight lines. The region R is a square region. Okay. So this is from engineering mathematics, from the topic multiple integrals, and the solution is. So let us denote this shaded region is R. R is the shaded region. Now, to evaluate the double integral, either you take first vertical strip or horizontal strip. If I take horizontal strip at any location here, if I take here, then this is lower limit, sorry, left side, y is equal to x is equal to minus y lower limit, x is equal to y upper limit. If I take here, x is equal to y minus 2 is lower limit, x is equal to y plus 2, 2 minus y is the upper limit. So limits changes. If I take different locations, the horizontal strip. So where you have the changes, where the change occurs, if I take here the strip, no problem. If I take here, if I take here, if I take here. Now, if I take here from this part, the location changes, that is the strip changes, limits changes. Okay. So, solution. This is O, this is A, this is B, this is I want to take. So once again, I am drawing the diagram. X-axis, this is Y-axis. Now this is 1 unit. This is 2 units. Join this. Join this. This is the region R. This is the origin. Let us denote this point A. This is already given 2. This is B and this is C. So joining C and A, from that above, if I take horizontal strip, limits changes. So first of all, the curves. So this curve is y is equal to minus x plus 2. I want to take horizontal strip, or you can take vertical strip dividing the region into 2 equal parts also. I mean 2 parts, which implies x value 2 minus y And this curve equation is y is equal to x plus 2. From this, x is equal to y minus 2. And this part is y is equal to minus x. From this, I can write x is equal to minus y. And this curve equation is y is equal to x. So for all the four boundaries, he has given already y in terms of x, but I want to express x in terms of y. Implies x is equal to y. So this is an indication by dotted lines. So by this, the red dotted lines, this region divided into two parts, R1 and R2. Okay. R1 and this part is R2. Okay. So now let O, A, B, C, O be the boundary of the given region R. Okay. Where O is equal to 0, 0. Now divide region R into two subregions R1 whose boundary is OACO and R2 second region subregion whose boundary is ABCA with horizontal strips. That is considering with horizontal strips. Horizontal strips. Okay. So in this region R1, R2 take horizontal strip. So here I am taking, this is the strip, horizontal strip, and here this is the horizontal strip. The strip name is P2Q. Here also P2Q. Horizontal strip is denoted by P2. Horizontal strips PQ. Okay. Or you can denote P1, Q1, P2, Q2. Now we have to find the limits. That means this given double integral R is now expressed as double integral over R1 plus double integral over R2. So in each subregion, we have to find the corresponding x and y limits because horizontal strip means x limits are functions of y. That's why I expressed each curve equation like this, and y limits are constants. So in R1, y limits are 0 to 1. This is 1. This. And in R2, y limits are 1 to 2. Okay. So in R1 region, comma, x limits minus y to y. Y limits, constant limits, 0 to 1. Am I correct? This is 0 to 1. Y limits. Y direction, y is equal to some number means it is a horizontal line. So when in this horizontal strip, it is moving from origin to one number 1 only. That is CA line only. Slide that strip from origin to CA. Next in R2, slide or move the strip, horizontal strip from this dotted line to number 2. So 1 to 2 y limits. Or you can find the boundary extreme points, point of intersection A, B, C by solving the corresponding two equations. From that way also you can get the y limits in each region R1 and R2. Okay. Next in R2, x limits y minus 2 to 2 minus y. Y limits 1 to 2. See, this part lies between y is equal to 1 and y is equal to 2. Y is constant limits. And in R1, is lies between the boundaries y constant limits y is equal to 1 and y is equal to 0. So this is x value y minus 2, and this is x value 2 minus 1. So y minus 2 is lower limit, 2 minus y is upper limit of x. Okay. So therefore, double integral over R xy dx dy is equal to double integral R1 plus double integral over R2. So in R1, constant limits y is equal to 0 to 1, keep outside, x limits minus y to y, first integrating with respect to x by keeping y constant, okay, dx into dy plus in the second integrals y is equal to 1 to 2, keeping outside, x limits y minus 2 to 2 minus y, again y constant with respect to x, first integrating, then with respect to y. Okay, so this is constant, y limits constant, CYNST means constant, this is constant. Okay, now so y is equal to 0 to 1, y into x integration with respect to x is x square by 2, or x power 1 is odd function, this is 0, minus y to y, and then dy plus y is equal to 1 to 2. So if I take here minus common, minus 2 minus y, this is also odd function, 0. Okay, y into x square by 2. In one variable integrations, if you compare, both are with respect to x odd functions. So minus a to a f of x dx is 0. Or you can do by direct integration, y minus 2 to y plus 2. Okay, dy, upper limit and lower limit. So 0 to 1, y by 2 into y square minus y square, in place of x put upper limit and lower limit, 1 to 2, 1 by 2, that is y by 2 into, in place of x put upper limit y plus 2, sorry, 2 minus y, right, 2 minus y. So minus y plus 2 whole square plus of y minus 2 whole square dy. Both simplifies to 0 plus 0 is equal to 0. So the value is 0. Answer is 0. This is the end of the question.